Now, straight into question 3 here. A security code consists of 6 digits, chosen at random from the digits from 0 to 9. The code may begin with 0 and digits may be repeated. So first thing to note, as we go from 0 to 9, don't fall into the trap. There's 9 numbers. From 1 to 9, there's 9 numbers. But if we include 0, there are obviously 10 numbers. And if you think of your the digits on a phone, for example, that will help come around to that realization. Anyways, so the code can be, it may begin with 0 and have digits may be repeated. For example, we could have something like this. Find out how many of the possible codes will end in 0. Now there are 6 digits in this code. So you can see there, 1, 2, 3, 4, 5, 6. Okay, so we can, any numbers can exist. Now, it will have to end with a 0. So effectively, this number here has to be 0. So as I've said there, there's only one option for this last one. However, there's 10 options for this one. There's 10 options, 10 and 10. So you can see I have that written down there. 10 times 10 times 10, etc., etc., times 1 for the last one. So 1, 2, 3, 4, 5. You can see there's 1, 2, 3, 4, 5 noughts or 5 zeros in the answer. Okay, so 100,000 possible codes there. Right, on to part 2. Find how many of the possible codes will contain the digits 2018 together and in this order. Okay, so for example, I have done out, so when we take out, remember there was 6 codes or 6 possible digits. So if we're saying that 4 of them have to come together, 1, 2, 3, 4, 2018, there's only one possibility of that happening. And then the next one, there's 10 and 10 possibilities. So that's one way. Now, however, this could happen when the 2018 happen here in the middle. Okay, so the way it's showing up there is covered to us down here. The second way that I just mentioned there, in other words, you have a number and then you have your 2018 and then you have any other number again that's represented by 10 times 1 times 10. And another way you could have it then is, of course, having any number, and then the last 4 digits be 2018. So effectively you can see there it's 10 times 10 times 1. If you want, you can say that it's times 1 times 1 times 1 times 1, because this has to be a 2. In other words, there's only one option there. This has to be a 0, only one option. That has to be a 1, only one option. And that has to be 8, so only one option. Alright, so go through this. Obviously, 10 times 10, that's 100. Or else, we could have this one, so it's 10 times 10, that's another 100. Or else, so there's another plus 10 times 10, that's another 100. So 100 plus 100 plus 100 is 300. That's part 2 of the question. Moving on to part B. Find A, B, C and D if n plus 3 factorial. Now just to give an example here, 3 factorial, you can find that on your calculator. Those factorial numbers are generally in the top left if you have a Casio calculator. So basically what that is, it's 3 times 2 times 1, which is obviously equal to 6. If you have, for example, 7 factorial, then it's 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. Anyways, we're asked to find out A, B, C and D in this equation here. As you can see, A n cubed plus bn squared plus cn plus d. And we are told over there that A, B, C and D are elements of n. In other words, they're positive whole numbers. So as you can see, the way I'm doing this here, I'm doing it with substitution. So I'm going to sub in n equals 0 for the first one. Okay, so this is going to be 0 plus 3, which is just 3. This is going to be 0 plus 2, which is just 2. And here we've got 0 plus 1, which is 1. 0 plus 1 is 1. So we get 3 factorial times 2 factorial over 1 factorial times 1 factorial. Now I've already mentioned what 3 factorial is. 2 factorial is obviously 2 times 1, and 1 factorial is effectively 1 times 1. So you can see I have all that done out there. So we get 12 over 1, which is 12. So 12 is equal to this here. Now remember what we said, n was equal to 0. So we'll be subbing in here for all of these n's, we're going to sub in 0, which as you can see there, effectively they all go to 0, and we're left with d is equal to 12, or 12 is equal to d. Alright, we're going to move on from that and sub in n equals 1 for the next one. Alright, now remember what we have up the top here. So now we've got 1 plus 3, that's going to be 4 factorial, you can see there. N plus 1, that's, we'll say 1 plus 2, sorry, I should say n plus 2, and I'm subbing in n equals 1, so that's going to be 3 factorial. And on the bottom line there, 1 plus 1 is 2, so we're getting 2 factorial times 2 factorial. Okay, all that is represented down here in this box here. Alright, 4 factorial, you can do that on your calculator or you can do it in your head. It's 4 times 3 times 2 times 1, that's 24, times 3 factorial, and 2 factorial is 2 times 1, which is 2. So we're getting 24 times 6, let's just show this on the calculator now. 24 times 6 divided by 2 times 2, which is 4. So divide that by 4 and we get 36. So 36 is equal to n cubed plus bn squared plus cn plus d. Now remember, we know d is 12 and we know all these all these n's are now equal to 1. So I pop that in there and it comes out 36 times 12, that's 24, and that's equal to 1a plus 1b plus c. 24 is equal to a plus b plus c. That's an equation there, and basically what I'm going to, as I go forward now, I'm going to get 2 more equations in a, b and c, and I'm going to solve them just like simultaneous equations. Okay, you can see on the screen right there now I have the next 2 steps done out. I sub in n equals 2 here. So now reverting back up to the top here again, at the very top of the screen there, just do a little box around that. We're now subbing in n is equal to 2, so I'm going to get 5 factorial multiplied by 4 factorial, and on the bottom line I'm going to get 2 plus 1, that's 3 factorial times 3 factorial. Okay, that's what I'm going to get as I move into n is equal to 2. You can see that's written right there on the screen. So I'm multiplying that out then, that comes to 80. And 80 is equal to n cubed plus bn squared plus cn plus d. At this stage now again, we know what d is, and we're subbing in n is equal to 2. So you can see that happening there, and that boils down to be another equation there in a, b and c. So 68 is equal to 8a plus 4b plus 2c. In order to solve these equations, there are 3 variables, so we need 3 equations. So this effectively means we've subbed in n equals 0, we've subbed in n equals 1, we've subbed in n equals 2. We're going to go once more, we're going to go for n is equal to 3. Up at the top here now again. So this is going to be 6 factorial. It's going to be multiplied by 3 plus 2, that's 5 factorial over 3 plus 1, 4 factorial times 3 plus 1, 4 factorial. So 6 factorial times 5 factorial over 4 factorial times 4 factorial. And you can see that there in that box there. You can see the sum's breaking it down there, and I've already done out is equal to 150. Okay, subbing in, as you can see there, my n equals 3, and I already know that d is 12. And the sums are all done out there for us, so that breaks down to be our third equation. 138 is equal to 27a plus 9b plus 3c. Okay, I've got the green box up there, I know what d is, and I now have 3 equations in the brown box, the pink box, and the blue box on the screen right there now. These are my 3 equations. I'm going to go about solving them to work out a, b and c. Okay, so you can see the three equations are listed over here. And remember how you do these when there's three variables? We basically work them down to when there's two equations with two variables, and then do what we normally do for simultaneous equations. Okay. So this is the first equation here, and I'm multiplying it by -2. So you can see what has happened to it down there. It goes to -2a, -2b, -2c is equal to -48. And this is the second equation. If I call that equation B, I'm just going to get that in there, that's 1b. Okay, so this is equation A, this is equation B, so obviously the other one is going to be equation C. Okay, so I've just left that alone there. You can see I have -2c and +2c, so they're going to cancel, and I'm left with 6a plus 2b is equal to -48 plus 68. That's equal to 20, and I'm going to call that equation D. Mightn't be the best idea calling these equations A, B, and C when the terms are in A, B, and C anyways, but that's just what, it's kind of just the way that I did it. Alright, we'll move into the middle section here, and you can see that I've taken equation A again, and I've multiplied it by -3, and this bottom equation here is effectively equation C. Okay, so multiplying this equation here by -3, I get -3a, -3b, -3c is equal to 24 times 3 is 72, so that'll be obviously -72. Okay, same story here again, the c's cancel. Remember, whatever cancelled over here were the c's, we have to get the c's to cancel here again. So the c's are gone now. -3 plus 27, that's 24a, plus 6b. Now we've got -72 plus, I think it's at 138, and that gives us 66. Okay, so that is equation E, as it were, there. Okay. Now, okay, so we're in here now, and we're looking at our two equations. So the top equation there, that's equation D, and the second one there is equation E. Okay, I've just taken them from over there. There's D, and there is E. Okay, so we're going to go through these now. These are just in A's and B's, so this is what I'll call all ordinary simultaneous equations, and we're going to solve these. So, okay, I'm multiplying the top one, as you can see here, by -3d, and I'm leaving the second one alone. So that'll become -18a minus 6b is equal to -60, and the second one gets left alone. So I've got -6b plus 6b, they're going to cancel. -18a plus 24a, that gives us 6a, is equal to -60 plus 66, that's equal to 6. So 6a equals 6, a is equal to 1. Remember, we wanted to find A, B, C, and D, highlighted there in green. We already know what D is, and now we know what A is. So I'm going to sub back there, I'm just going to sub back into the top equation there, in other words, equation D. I'm just writing a little d there, to work out what my B is going to be. Okay, so you can't really see it there, so I'll just pop it in there. 6 times 1, A is 1, so 6 times 1 plus 2b is equal to 20. So 2b is equal to 20. This goes across and becomes -6. 20 takes 6 is 14. So 2b is equal to 14. B is equal to 7. And now we know what A is, and now we know what B is, so we can use them. We can sub back in to either equation A, B, or C over here on the left hand side to work out C. Now it looks like what I have done down here. Now I am choosing, I'll just scroll back up the screen there. I'm going with equation B there. I'm just going to grab a highlighter, go with this one here, and I'm going to sub in A and B, and I'm going to work out what C is. So there's equation B written out there again in blue. Okay, so we know A, it's 1, we know B is 7. Okay, so I can 8 times A, I'll just add in an extra line here now. It's 8 times 1 plus 4 times 7 plus 2C is equal to 68. Okay, so as you can see there, I've subbed in my A and my B now. So that gives me 8 plus 28 plus 2C is equal to 68. 8 and 28 is 36. So I get 36, I can bring that over here. So 2C is equal to 68, take 36. And 68 take 36 is 32. So 2C is equal to 32, C is equal to 16. So I now have worked out A, B, and C, and D for that equation there. So that's the end of this question.